In this demonstration, I want to give you visual evidence that a capacitor stores charge. Alright, we've got our Van de Graaff generator again, and it's connected to a capacitor. Now remember, the Van de Graaff generator generates charge. The big sphere is going to become positive, and the ground will be negative. Alright? Well, I've connected the sphere to one side of the capacitor and the ground to the other. Alright, now I'm going to start the generator. You can't hear the belt this time because I've turned the sound down. Look what happens when we zoom in on the capacitor. This is clearly a capacitor. It has a conductive top, a conductive bottom, but plastic in between. Now there are balls inside the capacitor. Look what those balls are doing. They're bouncing up and down. Why do they do that? Well, those balls are called pith balls, and when they contact a surface that is charged, they slowly absorb that charge. So consider the pith balls that are sitting on the bottom of the capacitor. The bottom of the capacitor is connected to the sphere on the Van de Graaff generator, so it's positive. Those pith balls sitting there, then, are slowly absorbing positive charge. Eventually, they absorb so much positive charge that the electrostatic repulsion between them and the bottom of the capacitor, as well as the electrostatic attraction between them and the negatively charged top of the capacitor, is enough to overcome gravity, and they rise up to the top of the capacitor. Once they reach the top of the capacitor, however, they slowly start absorbing negative charge. At some point, that counteracts the positive charge enough that gravity takes over and they fall back down. However, at that point, they start absorbing positive charge again, and the whole situation starts all over. So the capacitor is clearly storing charge. One side is positive and the other side is negative, and that causes the motion of the pith balls inside.